Next speaker is Paul Strong from VMware. He's the CTO, externally facing CTO, so I don't know what that means. Probably there's an internally facing CTO as well. But he works with the global field and customers with respect to all of the initiatives and its partners. He has been part of the chair as well as the secretary of the Open Grid Forum for several years. He's a distinguished research scientist. He's been, prior to VMware, he was at eBay. And prior to eBay, I think he's also worked on some Sun Solaris containers and N1 products and in terms of B2B e-commerce areas. Again, I said, Paul, what do you do? Forget about work. What do you do off work? I said, he's a drummer. I said, part of a band? He said, yes. He actually has some songs up on the iTunes. You can talk to him more about what he has, but he's a rock star, and he's going to talk to you about, his presentation here on software-defined telco. Paul.
Thank you very much. Oh yes, the microphone's working. Fantastic. So thank you. My name is Paul Strong. I drum in a band. The joke is usually that I hang out with musicians. I'm actually not one. I just happen to hit things. So today I wanted to spend a little bit of time talking to you really around some of the changes we see happening around us in telco, but also learning from what we've been seeing in the data center. From my perspective, I see the telcos as definitely a special case. You are kind of the backplane, if you will, for the cloud and everything that's going on around there. But the needs in telco have always been special around capabilities around availability, fault tolerance, and performance and throughput. But nonetheless, what we've seen, certainly in my career when I was at Sun, I was vaguely involved in some of the NEVS-compliant hardware that we were building, is there that strong desire for the last 15, 20 years to move to a world where really the telcos are moving in the same way as everyone else, are wanting to take advantage of commercial off-the-shelf software solutions, open source, and things like that. For many, many years, we were in the space of highly vertically integrated hardware stacks that were very inflexible, built for very good reasons, usually around performance optimization and manageability. But what we're seeing happening around us in the data center, we're seeing some enormous changes, and those changes are beginning to come into the telco space as we realize that many of the problems that are specific to your industry are actually similar, and you can benefit from the same kinds of solutions. And one of the reasons that this has to happen is we're seeing this, that really there are business challenges on the horizons within the provider space, very specifically that the cost per subscriber, you can only drive it down so far, but unfortunately, the ARPU is going down there. In 2017 or thereabouts looks like an era where there's going to be, so how do we invest and monetize, and how do telcos provide differentiated value add to their customers? How do you create space, if you will, to do that? In the data center space, in IT, they've had this challenge for a number of years too. We wanted to be in a space where, historically 80 to 85% of people's spend has been keeping the lights on, but that's been insufficient, and they've wanted to redirect spend, and they've been using a certain set of technologies to change things. So what I wanted to do very briefly this morning was talk, one, about what we see happening around us with cloud, because what cloud is about is setting sets of expectations that ripple across all industries. And then secondly, talk about some of the technology trends that we see that are driving infrastructure as a whole. My background is actually building large distributed systems in general, and I have a systemic view of these things, and I see telco infrastructure and systems as just as another type of this kind of system. So we see profound change ahead. I do want to talk very briefly about the cloud thing, but not in a sense of the technology per se. What we see happening around us is a fundamental shift in how people think about technology and how it drives our lives, how we extract value. When I first stood on stage talking about cloud, I had to follow Werner Vogels when he was sort of launching AWS, and I was at eBay. And I made an assertion that cloud felt like outsourcing 2.0. This is, is it some kind of Jedi mind trick? We've seen these technologies evolve over time. There doesn't seem to be a step function. The mistake I made is that it was not about technology. It was about a consumption model. The notion of self-service, instantly provisioned, pay for what you use, cost-efficient, and elastic IT is something that we'd never, ever had before. But once we had it, things have fundamentally changed. You know, what you had to do in the past was you bought software, you bought hardware, you bought the people who install the software on the hardware, and you'd pay for them to maintain and manage it ad infinitum. And cloud has allowed organizations to actually be significantly different. It's allowed organizations to seek to commoditize the technology that does not differentiate them, and to seek to invest very specifically in the technology that does. So things like SaaS, VMware, we consume between 75 and 100 SaaS applications because we don't want to spend our time having admins install, monitor, manage, archive, CRM systems, or email. We want to build better software for our customers. So cloud changes things in a number of dimensions. And one of the most profound of those is it is lowering the barrier to entry to marketplaces for competition. And this is something that is really important in every sector. It really essentially democratizes innovation. And we see this happening with the over-the-top suppliers in your sector historically, right? I could be sat on a sofa somewhere. You could be somewhat infinitely more handsome than my good self. You might have a good idea. Today, you could go online and register yourself as a Delaware-based corporation for tax purposes. You could source all your back-office applications as SaaS. You could go to Alibaba.com in China and get physical goods manufactured for you that you then sell on Amazon and eBay and dropship via FedEx, DHL, and UPS. And you haven't left your sofa. This is actually something that's very profound and we're seeing becoming very disruptive. It means that technology has ceased to be a barrier to entry to marketplaces, or more to the point, the cost of acquisition of technology hasn't. And this means there are enormous disruptions going on in terms of businesses, and we expect to see this across the board. Enormous disruptions as technology essentially becomes a commodity that anyone can get at. And what they use technology to do is to undermine the fundamental assumptions that business models are based on. So let me give you a couple of examples. Encyclopedia Britannica. Some of you will be familiar with this. They had a $600 million a year business in 1990 selling beautiful leather-bound encyclopedias that you would put on your shelves and show to people for years. It'd make you look intelligent. You could point your children to them and they'd become intelligent or whatever. By 1995, Encarta had reduced their revenue stream to $325 million a year. And they were busy eating Britannica's lunch. Anyone seen an Encarta CD? Yep. No. These guys, 600 million users in 100 languages, and I don't mean readers. 600 million potential contributors in real time in 100 languages. They destroyed Britannica's business model. 2012 was the last year you could buy a brand new physical Encyclopedia Britannica. They're now an online business. Anyone remember these guys? In America in the 2000s, in the noughties, they were growing 15% year on year. And then these guys ate their lunch. I'm sure you've heard of them. My friend Adrian happened to be the guy who did all their Amazon stuff. These guys went out there and they destroyed Blockbuster, who were renting videos. They said, we'll send you them over the internet, one after the other, in the order that you like them. You'll never pay late fees for not returning your CDs on time or your DVDs. But they saw the horizon and they saw these guys coming. And so they bifurcated their own business model. Originally, they were shipping DVDs and streaming for the same price. And they sat there and they said, I don't want to be in the physical goods logistics business. It's too expensive. I have to have warehouses. I have to post things. I want to get into streaming and only streaming. And so they split their business. Originally, they did it for all the same price. They said, no, they're two different things. And then the streaming business has eaten and destroyed their previous business. What we're seeing here and what is so fundamental for all of us is technology is now being used as a weapon of mass disruption. It is being used asymmetrically. The small and nimble have access, small and nimble with nothing to lose, have access to the same technology as the large leviathans with everything to lose. And this is applicable in every marketplace. It's just a case of how quickly and when. Disruption is coming to somewhere near you fairly soon. Now, all of this disruption is based on a set of technology trends. For me, that's what I'm really interested in. And these trends have really not shifted much in the last 30 years. It's just a case of velocity and timing. Let me talk about two things, what we see happening in the application space and what we see happening in the infrastructure space. From the application space, we started with monolithic applications in my youth. You may not be able to see the gray hairs, but my first machine out of school was a VAX 11780, all my own, when it was new, not old. Machines used to be, on applications, used to be monolithic. We've gone through client-server, 3-tier, N-tier, to the applications we build today that are highly distributed and disaggregated, microservices. We expect this to be the trend where applications continue down this route. Most of our customers and most of you will be running traditional client-server applications and all sorts of things, but the future is different. There are applications that are designed fundamentally differently. The old stack used to be this: presentation, business logic, and data. There was a database beginning with O. There'd be business logic and a stateless client. What we've seen is the applications are now changing significantly, and we see this in your space absolutely as well, a fundamental shift here. The new world where the client is actually, it's mobile, right? You've got a device with vast numbers of sensors, GPS, accelerometers, video, audio, and everything else that goes with it. Now sends back a vast amount of data into the cloud, into the underlying infrastructure that then is processed. What returns is an infinitely personalized experience in real time that allows organizations to differentiate themselves. This is what telco has to do, to provide differentiated sets of services through things like service chaining. Same problem. Everything has to be done in real time and personalized massively to drive differentiation. At the back end, in the middle tier, we're seeing a shift around business process re-engineering. So what I talked about with Britannica and everything is a world where technology is no longer used to optimize the way you always used to do things. Technology is now used to do things differently. This is what we see happening. And at the back end, we see real-time streaming analytics. We see data being used in vast amounts to sit there and have understanding of mass demographic behavior, and then being able to infinitely personalize interactions, whether they're with other businesses or with individuals, in real time to maximize the value of each and every interaction that you've got. This is a fundamental shift in terms of the applications and services. The other trend that's been going on, I tend to think just of these two things, the applications evolving, as I said, from monolithic through client-server, 3-tier, N-tier, to highly distributed and disaggregated. And by the way, something I want to leave you with on the application side is all the assumptions are changing. So when I was young, which was a long time ago already, when we built applications, we tended to think that if I wanted to build a reliable application, I needed a reliable platform to build it on. And so I would go for something that was fault-tolerant underneath if I had a fault-tolerant thing that I wanted to present above. But that is not the way applications are built and designed anymore. They're done exactly the same way that we think of storage. What do you have when you have storage today? You have RAID. You create reliability on top of inherently unreliable lower layers of infrastructure. And we see that happening in the application stack. People are building applications with different sets of assumptions. They're assuming that things break. They're assuming that they can't scale up. So they build applications with the expectation of failure. They build applications that are inherently resilient. That yes, if you lose one, you lose 1/100th of your capacity and maybe 1/10th of your slice of your database index. You don't ever lose the whole thing because the whole thing is never in one place at one time. There's an assumption around state, around consistency and coherence. It's fundamentally different. Now, on the infrastructure side, we're also seeing a fundamental change, a movement away from monolithic implementations. Think about big servers with infinitely thin pieces of wet string that used to connect them together in my youth. And what we see now is everything is moving towards a fabric of resources. This fabric of resources, in my view, extends all the way from the back end in the cloud all the way out to the individual devices that we have in our hands here. Okay? What we have seen for the last 30 years is the constant ebb and flow and movement of functionality and value backwards and forwards across the network. We started with monolithic apps on monolithic machines. We got cheap microprocessors on the desktop, and so we put applications there. We got the corporate LAN, so we could share file and print services, and then we shared databases, and we built client-server applications. Then we discovered we couldn't manage the client because the end user wanted to, and there was the internet in the way, and we built stateless applications. Now, we're building these cloud mobile applications. But the story is of the constant ebb and flow and movement of functionality and value backwards and forwards across the network. In terms of the supporting infrastructure, for me, there are two big shifts and changes that we've seen in the last 10 to 15 years. And I saw this very specifically both where I am now and in my previous life at eBay. The first is that we see ruthless standardization. Diversity is your enemy. So diversity is what drives complexity and what drives cost of management, of infrastructure, and everything else that goes with it. The number of things you manage is not the problem. The problem is the number of types of things you manage and the rate at which they change. So it's not the number of servers, it's the number of server vendors and the rate at which you have to change the firmware. It's not the number of OS instances, it's the number of OS types and the rate at which you have to update and patch them. The number of terabytes per admin is not interesting. It's the number of LUNs you have to map and remap on a weekly or a monthly basis. Diversity is what's killing it. What we've seen in the last 15 years is the data center is becoming homogeneous. And infrastructure is becoming more homogeneous. In fact, x86 has become it. It has become the de facto platform for choice for almost all new applications and for data centers in the cloud and elsewhere. It is also already the default platform of choice for data by capacity. The vast majority of the world's data is directly attached on spinning Rust to x86 servers in the data centers of Amazon, Google, Facebook, eBay, and anyone doing big data analytics. And now we're seeing that this same x86 architecture is becoming the default, certainly for networking. It's beginning to move that way in the data center, and we're beginning to see that in the telcos, in the service provider space as well. Once you standardize and get rid of diversity, yes, there is risk in going with one architecture potentially, but we've seen a set of wars and we're at the end of them. It means we can now build automation tools that aren't automatically deprecated when one of your vendors changes their products. This is the enormous opportunity. You need competition, but you do need ruthless standardization. The second big thing that's happened here is virtualization. You'd expect me to say that. I haven't talked about VMware at all yet. I sometimes joke that working at VMware is like being on Sesame Street. Today's show was brought to you by the letter V. We're going to talk about it all day long. But virtualization for me is magic. What it allows us to do is something that's very profound, and is when we talk about network function virtualization, it fits exactly into this. What virtualization allows us to do is to separate applications and functions from physical infrastructure. Once we separate them from physical infrastructure, we can do very interesting things. We can move capabilities around the network and between systems from one machine to another in order to give performance improvements, so from a smaller machine to a larger machine. We can go from a breaking machine to a working machine. We can move applications, once they're encapsulated in this container called a virtual machine or whatever. We can replicate them from one location to another for business continuity. We can push them out into the cloud, and we can pull them back in. So for 15 years, we spent our time separating the application from the physical server, and that's what VMware was famous for. What we see happening now is we're also separating it from the other parts of the infrastructure. Because unfortunately, your applications, remember I talked about them, they're not singletons. They don't run on one OS instance. They typically run across a network of machines. And in the data center, what we saw was that basically, yes, I could provision a VM incredibly quickly. And by the way, we can do fault tolerance between VMs these days, which is pretty darn cool. But unfortunately, your networked apps, they don't, you flip a VM on, but the trouble is you might have to change the IP addresses. You might have to do load balancer changes, firewall changes, a whole set of other things. And before you know about it, what should take minutes turns into hours, days, and weeks, depending on the maturity of an organization and their level of automation. And so that's why we spent money on a small startup 2 years ago called Nicira, which I'm sure you've all heard of. We spent $1.26 billion. I sort of should say billion like this, I guess. for 100 people and a very early startup. Why did we buy them? We bought them because they allow us to separate applications and functions from the physical network underneath and encapsulate them in a notion of a virtual network. Then we can put networking capabilities like routing, firewalling, and load balancing as virtual appliances within this virtual network. Now we can provision entire network distributed sets of services incredibly dynamically. We can also make a single network span from one location to another as far as a data center is concerned. And we get this enormous capability by shoving all of this into the underlying hypervisor, is that we can do scale out of capabilities like load balancing, firewalling, and routing. And we can do very fine-grained isolation, a thing we call microsegmentation. This starts getting very interesting. It allows us to really start thinking about how we manage function and software and applications in a way that we never could before. The reason we can do that is in the past, the major problem in application and function management is that it's very hard to do at scale. Many data center customers have thousands of applications and services, each of which has to be created, purchased, architected, integrated, tested again, installed, monitored, managed, archived, and everything that goes with it. This is very hard, managing the life cycle of your apps, services, or functions. And when you have thousands of them, it doesn't scale very well. But when you put an application or a service or a function into a container, whether it's a virtual machine, a virtual network, whether it's a lib container, whether it's a Solaris container, as long as there are a small number of them, you can automate them in a way that you never, ever could before. You can't automate all those individual things very easily. They're too complicated. But you put them into a container, and you automate the life cycle of the container. By proxy, you automate the life cycle of everything you could put in the container. And so this creates an enormous opportunity. Now we can automate in a way that we never, ever could before. This is the thing we call the software-defined data center. And these technologies have become what we see dominating the commercial off-the-shelf business, if you will. This is becoming not quite commodity, but it is absolutely where technology is heading. It's really, we separate applications and functions from underlying physical infrastructure through virtualization. Once we've separated them from network, compute, and storage, then we can automate their management. So this is what we see happening around us. This is what we've seen happening inside commercial data centers. And this is becoming the way that the industry thinks of infrastructure. This is the way we think of systems. This layer of software we're building, I view as a kind of meta operating system. But it's getting us out of the business of caring about physical infrastructure. The infrastructure is becoming flatter from a networking perspective and more homogeneous. And that affords us enormous opportunity in creating much more agile sets of services and applications. If you think about what you want to do with service chaining, it takes us to a world where we can start focusing on the value and the functionality and stop focusing on the physical infrastructure underneath. And it is reaching a level of maturity and pervasiveness in the data center that is now ready for adoption in the telco and the NFV space. So with that, I've overrun massively, I know. But I'll give you a thank you very much for getting up so early. I know how hard it is. This is my second week on the road. I'm not entirely sure what time zone I'm in. It's been a pleasure speaking to you. Thank you very much.
Thank you.